In this lesson, you will learn how to graph quadratic functions. Now remember, quadratic means that we have a term where something is raised to the second power, and a function is something where we have y equals. So for example, if we had y equals x squared minus 3, that would be a quadratic function, because we have y equals makes it a function, and the x squared term makes it into a quadratic function. Now when you graph a quadratic function, we're going to get shapes that look like this. And some terms to know before we get into the actual graphing, we need to know the shape itself, which is called a parabola. So this shape that you see here is a parabola. And this will keep going forever this way, and then forever this way as well. It's going to keep going infinitely. And that's a parabola. Next term is what's called the axis of symmetry, which is a line that divides an object into half and creates mirror images of each other. So in this case, the axis of symmetry will go right down the center of the graph, just like that. We're now on the left side, we have an identical image as to the right side. And then we also have the vertex, which is going to be this point right here. It's either the lowest or the highest point of a parabola. And then we have an x-intercept and a y-intercept. X-intercept is where this crosses your x-axis. So your x-axis goes left to right. So this point right here and right here would both be your x-intercepts. The y-intercept is where it crosses the y-axis. And right here, this is centered on the y-axis. So in this case, the vertex is also the y-intercept, which many times that will not be the case, but in this case it is. So make sure you know those different terms. Now as we get into graphing, our objective is to notice patterns. And if you can recognize patterns, then this lesson shouldn't be too bad, because that's all we're really doing for today. Where here we have an equation, y equals x squared. This is the most basic function. And if you were to plot points, let's say you put a -3 in for x, then we have -3 squared, or 9, for y. If we put a -2 in for x, we have a -2 squared, or 4, for y. -1 gives you a 1, 0 squared gives you 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So if you were to plot each of these points, you would get this graph right here. And I'm assuming that everyone knows how to graph, and when you graph, you would get this parabola. Now from here, what we're doing is we're going to try to manipulate this graph to see what happens. So we're going to put numbers in the front of x squared, we're going to add things, subtract things, we're going to put things in parentheses, and we're going to see what each of these different things do to this initial graph. Okay, so here we have y equals x squared plus 2. And the question is, what does adding 2 do to my graph? So if I plot a bunch of points, let's say -3 for x, we have -3 squared is 9, plus 2 is 11 for y. -2 squared plus 2 gives me 6 for y. -1 squared plus 2 gives me 3, and etc. If you plot each of these points, you're going to get this graph right here. So notice what happened. This plus 2 shifted the graph up 2 to this point right here. So this plus 2 is going to be your vertical shift. So this moves it up 2 for this equation. Okay, now what about a -2? Well, we can probably conclude that it's going to move it down 2. So let's plug in some points. -3 for x gives you -3 squared, which is 9 minus 2, or 7. -2 squared minus 2 is 2, and etc. So you plug in all these different points, and you get this graph right here. And notice, yes, it moved it down 1, 2 places to right here. So this -2 moved it down 2. Okay, so take note of that pattern. The number outside, the addition or subtraction, is going to move it up or down. Now, what if we had something in parentheses with the squared? So x minus 1 squared. Well, if you plug in some points, let's put in -3 for x. We get -3 minus 1, which is -4, squared gives you 16. -2 minus 1 is -3, squared gives you 9. -1 minus 1 squared is 4, and etc. When you plot each of these points, here is the graph that you'll get. And notice that it shifted to the right 1. The vertex is now over to the right 1. So this -1 in parentheses moved it to the right 1, which is kind of counterintuitive. It's a minus sign, yet it moved it in the positive direction on the x-axis. So this minus moved it to the right 1, and then we can assume, and we'll prove in a second, that a +1 would probably then move it to the left 1. So let's try this one. You plug in some points, -3 for x, we get -3 plus 1, which would be -2 squared gives you 4. -2 plus 1 squared gives you 1, and etc. You plot the points, and notice it does move it to the left 1, right over here. So the vertex is at -1. So this, in parentheses, moves it to the left and right. The number on the outside, added to the square term, moves it up and down. And now what if you put a number in the front of the squared? So here we see a 2. We put a 2 in front of the x squared. So you plug in some points. You have -3, plug that in for x. So now we have -3 squared is 9 times 2, gives me 18. -2 squared times 2 gives me 8, and etc. So now if you were to graph each of these points and compare that to the original graph of just y equals x squared, here the red line is y equals x squared, and the blue line is y equals 2x squared. Notice that it became skinnier. When you put the 2 in the front, this became skinnier. And the way to maybe think of this is think of the 2 as kind of like slope, where we learned that with slope, the bigger the number, the more steep it's going to be. Now here we have a bigger number, so it's bigger than 1x squared, so therefore it's going to become more steep, which is what's happening. It is more steep, which then makes it more narrow as well. So if you had y equals 1/2 x squared, we can assume that because the number is smaller than 1, then it's going to become not as steep or more wide. So if you plug in points, we can figure this out to be true, where if you plug in -3 in for x, we have -3 squared times 1/2, which would give you 9/2, or 4 1/2. -2 squared times 1/2 gives you a 2, and etc. When you plot these points and compare that to the original graph, then you see the red line is going to be y equals x squared, and the blue one is going to be the new y equals 1/2 x squared. So what happened is this did become more wide. It was less steep because this number is smaller than 1, and therefore it's more wide than y equals x squared. And then lastly, what if the number in the front is a negative? So if you plug in points, -3 in for x, make sure you do order of operations, so you square first to get a +9, and then make it into a negative after the fact. So this would become a -9. -2 squared would be 4, then times the -1 makes a -4. And then do that for each of those points, and when you graph them, notice the graph becomes upside down. So this number in the front, if it's a negative, will make the graph turn upside down. So now we have seen what every different part of the function will do to the graph, and now putting it all together, and to recap, if this is your general equation, then a changes the width of the parabola. So the number in the front of the squared term changes the width, whether more skinny or more fat. If it's negative, it flips the parabola upside down. H, this number in here inside of the parentheses, will move the parabola horizontally. And k, the number out being added or subtracted, will move the parabola vertically. So now here's an equation putting everything together. And the question is, what is the graph going to look like? Well, we see it over here already graphed for you. But the question is, how do you determine, if it's more steep, more wide, facing up, facing down, etc.? So the first question to ask is, will it be skinnier, fatter, or normal size compared to just a regular y equals x squared? Well, the 2 in the front is bigger than 1. This 2 changes the width of the parabola, whether it be skinnier or fatter. Because it's bigger than 1, the slope is steeper, so it's going to be more skinny. Now the next question is, will it be upside down or right side up? Well, because it is positive, it's going to be right side up. And as you see on the side, that is the case. Next question is, what is the horizontal shift? Well, horizontal shift is determined by the number inside of the parentheses. So the -2 tells the horizontal shift, so it's going to move 2 spaces. And remember, the one in parentheses is kind of counterintuitive. The -2 actually moves it in the positive direction, so it moves it to the right 2. And then the vertical shift is determined by this +3 out here. This one is intuitive, where we see the +3, meaning it's going to move in the positive direction 3. So the vertical shift would be up 3 in this case. So then the next question is, what is the vertex? Well, the vertex, we know where it starts because it's shifting to the right 2, so over 1, 2, and then it's going up 3, 1, 2, 3. So the vertex would be to the right 2, up 3, to get the point 2, 3. So these are questions that we can answer based off of the function. Now, some other questions that you need to know how to answer would be, what is the axis of symmetry? Well, remember, the axis of symmetry is a line cutting down the center of the parabola. So this line right here would be the axis of symmetry. And the question is, what is the equation of that line? Well, notice it's going through the x values of 2. So no matter where I'm at, x will always equal 2. I could be up here at this point, x will be 2. I could be up here, x is 2. It doesn't matter where I'm at on the line, x will always be 2. So the equation is going to be simply x equals 2. Now, 2 other questions that you need to answer is, what are the x and y intercepts? So the x-intercept, remember, is where it crosses your x-axis. And on the x-axis, remember, that y will always equal 0. So here in the x-axis, it's not up or down. Y would be 0 for the x-intercept. So you plug a 0 in for y and you solve for x. Now looking at the equation, or the graph right here, you can see that it's not going to cross over the x-axis. So in this case, there would be no x-intercept. But if you didn't know the graph, or you're just trying to solve without seeing what the graph looked like, then you would need to know how to find the x-intercept. And how do you determine, based off your solution, that there would be no x-intercept? Well, if I solve this for x, what I do is I subtract 3 from both sides to get the x squared term by itself. So we get -3 equals 2 times x minus 2 squared. Get rid of the 2 by dividing. So now I have -3 over 2 equals x minus 2 squared. And then to solve for x, I can get rid of the squared by taking the square root of both sides. When I take the square root of both sides, now I have x minus 2 equals plus or minus the square root of -3 over 2. And notice at this point right here, we take the square root of a negative number. That's going to be imaginary. And yes, we have learned how to simplify imaginary numbers, but if the solution is imaginary, that means really that there is no real solution. So it's not going to actually cross over your x-axis. So therefore, we can conclude, based off the imaginary number, that there is no x-intercept in this case. And then for y-intercept, same concept, where we know on the y-intercept is where it crosses the y-axis, and x will always be 0 for the y-intercept. So plug a 0 in for x, and then solve. So then solve this, we get -2 squared, which is going to be 4, and then 2 times 4 gives me 8. 8 plus 3 is 11, so my solution would be 11, and that should be an 8 right there. So where it crosses your y-axis would be up here at 11. Let's work through one other example, answering the same questions to make sure that we understand how all of these components work. So here's one more where you have y equals negative x plus 4 squared minus 3. First question is it going to be skinnier, fatter, or normal size? Well, the skinniness is determined by the number in front of the squared term, which in this case is a 1, a negative 1. While the 1 is the average size, so I guess when I'm asking this, you're comparing this to y equals x squared. Y equals 1x squared. So here is still a 1 in front, so the steepness will be the same. It's going to be normal size. It's a negative, so it's going to be upside down. And then the horizontal shift is determined by this 4 in here. So this 4 moves it horizontally. And it's going to be in the negative direction 4, even though it's a positive 4 in here, because this one is kind of counterintuitive. So a horizontal shift in the negative direction, which would be to the left 4. And the vertical shift is determined by this negative 3. So the negative 3 would truly be in the negative direction in this case, which would be down 3. And then the vertex, since we shifted to the left 4 and down 3, that would be negative 4, negative 3. So when you graph this, we would get something like this, where it's over 4 and then down 3. The vertex is here, is facing upside down. And the next questions would be, what is your axis of symmetry? Well, that is going to be the line going down through the center, down through the vertex. And what's the equation of this line? Well, it's over 1, 2, 3, 4. It's over here, x equals negative 4. And that's going to be the equation. The equation of the vertical line would be x equals negative 4. And then your x-intercept is where it crosses your x-axis. So x-axis y would be 0. So plug a 0 in for the y and then solve. So you can add 3 to both sides. You're going to get 3 equals negative x plus 4 squared. You can divide both sides by negative 1 to get rid of this. So now we have negative 3 equals x plus 4 squared. Get rid of the squared by taking the square root of both sides. And notice right here, at this point, once again we have the square root of a negative number, which would make this imaginary, which would mean that there is no x-intercept. If there was an intercept, you would just simply solve the rest of that for x by subtracting the 4 over to the right. So in this case, there is no x-intercept once again. And then y-intercept is where it crosses the y-axis, and on the y-axis, x will be 0. So plug a 0 in for x and solve. We get 4 squared is 16. So we have negative 16 minus 3, which gives you a negative 19 as my solution. So we've learned now how to answer the different questions concerning the graph. And now we're going to finish off by actually graphing everything completely by ourselves. And not by plotting points, but by using the shortcuts that I've shown you. So here, okay, we know the vertex pretty quickly because this negative 2 means it shifts to the left, or sorry, to the right 2. So it's a negative, but it's going to actually move to the positive direction, which would be to the right 2. And the negative 4 is your vertical shift, moving it down 4. And it's down because it's a negative. So your vertex would be to the right 2, so positive 2, then down 4 makes it a negative 4. So my vertex would be 1, 2, then down 1, 2, 3, 4 to be right there. Okay, that's your vertex. And now the question is, what other points can we find from the vertex? And yes, we could plot points. So plug in something for x, see what y is equal to. But a shortcut that we can use is using the number in the front right here. So it's an assumed 1. It's positive. We know it's going to be facing up. So it's going to look something like this. Now the question is, if I go over 1, how far up am I going to go to find another point? So from the vertex, if I go to the right 1 or to the left 1 or right 2 and left 2, how high up do I go to get my other point? So what I can do is a shortcut here. if it's just a 1, then what I do is if I go to the right or left 1, I'm going to go, in this case, up, because it's positive, I'm going to go up that number squared. So if I go to the right 2 or the left 2, I'm going to go up 2 squared. So 2 squared, or 4. If I go to the right 3, I go up 3 squared, and etc. So if I go from this vertex, if I go to the right 1, I'm going to go up 1 squared, which would just be 1. If I go to the left 1, I go up 1 squared as well to get that point. And then if I go to the right 2, I go up 2 squared, so which is going to be 4. So over 1, 2 from the vertex, 1, 2, then up 1, 2, 3, 4 to get this point right there. And same thing on the other side, because it's symmetric. Go to the left 2, I also go up 4. And then I could find another point, 3 up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 right here would be another point. And then negative 3 to the left 3, go up 9 as well. And I connect the dots, and I'm going to get this graph right there. And I missed the point a little bit right there, but you get the idea. This would be the graph for this equation. Now what if you had a 2 in the front? So still the same vertex, where I go to the right 2, down 1, 2, 3, 4. But the question is, from here, if I go to the right 1 or to the left 1, how high up do I go in this case? Well, kind of the same concept. If I go to the right or left 1, I'm going to go up, and it's going to be 1 squared times this number in the front, because this is kind of like your slope, right? So 1 squared times 2. If I go to the right 2, I go up 2 squared, and times that 2. If I go to the right 3, I go up 3 squared times 2 again, because of that 2 right there. So from the vertex, if I go to the right 1, I go up 1 squared times 2, which would be 2. So there, and then to the left 1 would also go up 2. If I go to the right 2, I go up 2 squared times 2, which would be 8. So I go to the right, that's not 2. If I go to the right 2, I go up 8, 1, 2, 3, 4, 5, 6, 7, 8 right here. And I go to the left 2, I go up 8 as well. And then 3 squared times 2 would be 18. So I go to the right 3, I go up 18. And that's going to be off of this graph. But I can connect the dots and try to go through the points this time and get something like this right there. It's not the most beautiful parabola, but you get the idea of where the graph would go through. And then one more, if it was 1/2 in the front, same thing. I know the vertex was over 2, down 1, 2, 3, 4. The 1/2 means if I go to the right 1, I go up that 1 squared times that 1/2. That's right here in the front. If I go to the right 2, I go up 2 squared times 1/2. If I go to the right 3, I go up 3 squared times 1/2. And so from the vertex, go over 1, I go up 1 squared times 1/2, which would just be 1/2. It's about right there. To the left 1, up 1/2 as well. To the right 2, I go up 2 squared times 1/2, which would be 2. So I go to the right 2, I go up 2 right there. And also to the left 2, I go up 2 as well. And I can connect the dots and get this parabola. So a little shortcut for graphing. Once you have the vertex, use this number in the front to determine where to find your other points. And that concludes our lesson for today. We will see you next time.